We're starting off now then with the section for 11D, which is about position vectors. So imagine you had a coordinate 3, 2, and we translated it by the vector 4, 0. Vectors, you probably saw these the first time ever when you were doing translations, moving shapes around. So you might think that we can just say, well, okay, it goes to 7, 2. But the issue is these, well, they're not both vectors, okay? And if we want to add vectors, we need them to be conformative. In other words, we need like the vectors to be exactly the same. So instead of thinking of A as a coordinate, sometimes we want to think of OA meaning from the origin, OA as a position vector 3, 2. And then we could do something like this. Or sometimes this is just said as A. You might just say A is a position vector. Okay? So the position vector of A, it actually means a vector. This is called OA, where O is the origin. This is deceptively simple and seems very obvious. You know, they're exactly the same, aren't they? Well, in a way, yes, but this is a coordinate. This is where something is, and this here is a vector. Okay, some of the harder questions later involve, you know, thinking of A as a position vector, thinking of that as OA, and then it might say something like, what is AB? Well, you might be given the position vector for OA, and you might be given the position vector for OB. And you have to sort of use that together to find this one here. And it's generally quite badly answered because the language in the question or whatever it is, people don't appreciate that it's useful to write OA or OB. Let's do some examples. So the points A and B have coordinates. Find in terms of I and J position vectors. Well, the position vector for A is written as this. It just means how do you get from the origin to A? Well, it's exactly what you would expect. You go 3 to the right and you go 4 up. That's what that means. How about OB then? Well, again, as it looks, unsurprisingly. So OA is something like this. OB is something like this. Well, what's AB then? It helps to write out the dot to dots with the letters. If you want to find something about AB, why don't we start with something like this? OA plus AB equals OB. Let's try and link together all the bits of information that I've got. Now it's much, much easier to see that, well, OA, I could write OA as 3, 4. OB, I could write as 11. Sorry, no, I don't have that one. That's what I'm finding. OB, I could find as 11, 2. And I could sort of inspect, I suppose, how much do I need to add on to get here? Or I could rewrite this as AB is equal to OB minus OA. That's another way I could do it. And I'll get my answer of 8 and minus 2. I do heavily recommend this though, because this is quite important as the questions get more difficult. A further example then, here's OA, here's AB. What is the position vector of OB? Well, what is OB the same as? It's the same as something that starts at O and ends at B. So OA starts at O. Dot to dot, you need to get from A to B. Well, AB is talked about in the question as well. So 5 and minus 2 plus AB is 3, 4. And it's ready for us to get the answer, 8, 2. What does this mean? The exact value Surd form. When do you use surd? Often with square roots. Magnitude is what this means here. Okay, so we need to do Pythagoras. Pythagoras with OB. So we apply Pythagoras to this one here, and we get 2 root 17. That takes you up to exercise 11D. I'm going to skip the next part and come back to it finally because I think this is the most difficult. Let's talk about 11F. Finish with this video. So vectors are used extensively in mechanics. What are they used to show? Well, they are used to show when something has a direction, okay, a direction, and you will see that certain things can be, okay, so a direction and a magnitude. That's when we would use them, a direction and a magnitude. So this might be quite a new idea for some of you, but there's a distinct difference between something like velocity. Velocity is a vector, okay? You can say velocity is 3 kilometers an hour in the x direction and 4 kilometers an hour in the y direction. That is different to speed. Speed is just speed, okay? It only has a magnitude. It's not as detailed, okay? Vectors are more detailed than this. So velocity and speed are not the same, which is why your mechanics teacher will not like you saying speed when you should be saying velocity. Displacement, again, sounds quite formal for the detailed vector form. It's got a negative, so it means it's over to the left, and 12 means it's up there somewhere. Well, that's like saying distance, but distance is the one that's just got a magnitude. It's just 13. So, unfortunately for you, as well as sort of writing things perhaps like this or like this, you need to be on the lookout for words, for example, when people say speed. If they say speed, you'd need Pythagoras as well. So all of these would be scenarios to use Pythagoras with vectors. An example here. So a girl walked 2 kilometers due east and 3 kilometers due south. What's the total distance traveled? The total distance traveled. Not the distance away from the origin, but the total distance traveled. Well, you add up the parts of the journey. The position vector of B relative to O. So, what is OB? Well, it was, we could break this up. We don't really need to, but let's break it up anyway. So it was from going from O to A and A to B. O to A was 2, 0, 2 to the right, nothing about up or down. AB was 0, minus 3. So in other words, it should be 2, the position vector of B relative to O. No, that's incorrect. That should be minus 3, okay? Because direction is important. Magnitude of OB, okay? So this is where we're going to apply Pythagoras. The bearing of B from O, bearings are measured always from the north line, okay, clockwise, and it needs to be 3 digits. You know that this here is 90 degrees. You need to find this angle here and add this together of B from O. So 90 plus tan, the bearing of B from O. So I think this again is actually incorrect also, because we should be talking about if we are traveling east and then south, and we are in a southeasterly direction, we would be expecting an answer perhaps like 100 and something. Let me just change the units on my calculator so I can do the question. So inverse tan of 3 over 2 plus, yes, So that's this bit here is this bit here, but for some reason they've forgotten to add the 90. Okay, so it should be 146.3 degrees. Okay, so just a note there about 2 inaccuracies in the question, I'm afraid. So quick fire questions. Well, let's kind of put that together. What is the speed for this velocity here? So this one, speed, means Pythagoras. It means 5. (49) and the 16. So here I'm thinking root 65. Okay, so we need to be on the lookout for words such as speed. A further example, often the questions get a bit more detailed. It could ask you to use things like the sine rule, the cosine rule, and things like that as well. Because as a general rule, the easier questions from A-level tend to be the hardest or the very hardest from GCSE. In the interest of how much space I have, I'm just going to show you this one here. So have a quick read, pause the video, have a go, and then watch. So we start at the origin, we walk 15 kilometers on this bearing. So you're going in this direction, sort of, east, a little bit southeast, until you reach A. He walks 9 kilometers on a bearing. On a bearing means which direction the arrow for the vector is pointing. So that's 240, so over here somewhere. And then often using triangles in questions is the way it goes. The position vector of A relative to O. Well, we've got this angle here. What else do we have? We have the 15 kilometers, so we can do some SOHCAHTOA. Okay. Notice it does say the position vector, so you need to find out this one and this one as well. Okay. Magnitude of OB. Well, how do we do this one? Since we know that this is 15 kilometers and we know that this one here is 9, we could find out that this one here is 60, and then we have a missing angle. So we have a cosine rule where we have the angle included by these sides here to find OB. So we could actually use cosine rule in this situation. The bearing of B from O, so you know that this is 120 degrees. You'd need to find this one out and add it on to 120 degrees. Well, how would you do that? If you know these sides here, you've just found this one, you could find, well, sine rule is probably the easiest. Using this one, and then this one, this one. Sine rule should be able to give you an answer. Okay, so one thing I'd sort of point out about this is there's a very, very strong link to mechanics as well for vectors. So you will be given the equation of F equals ma a lot. And both force and acceleration can be vectors. So if you spot any questions about force, mass, acceleration, these would be the ones I would have a go at if I were you.